Now we are going to study about Planck's quantum postulates. Max Planck in Germany examined the whole situation critically regarding the nature of vibration of the linear harmonic oscillators with radiation within a cavity. In 1900, he put forward an important hypothesis. A blackbody radiation chamber is filled up not only with the radiation but also with simple harmonic oscillators or resonator of the molecular dimensions, which are known as Planck's oscillator or Planck's resonator. They can vibrate with all possible frequencies. The exchange of energy between matter and radiation does not take place continuously, but energy is emitted or absorbed in the form of packets or quanta or as photons. The energy of photon is proportional to the frequency of radiation. E is equals to h nu, where h is Planck's constant, its value being equal to 6.62 into 10 raised to power minus 34 joule second. The small unit of energy of photon is h nu. The emitted or absorbed energy can be in multiples of small unit called as quanta, that is 0 h nu, 2 h nu, 3 h nu. Planck's law of blackbody radiation. In 1901, Planck derived an empirical formula to explain experimentally observed distribution of energy in the spectra of a black body. This formula was based on following postulates. Okay. In 1901, Planck derived an empirical formula to explain experimentally observed distribution of energy in the spectrum of a black body. This formula was based on the following postulates. A blackbody radiation chamber is filled up with radiation and simple harmonic oscillators or resonator of the molecular dimensions. The energy is given by E is equals to nh nu, where h is Planck's constant, nu is frequency of the oscillator, and n is a number which can take only integral values such as n is equals to 0, 1, 2, 3 up to so on. The exchange of energy between matter and radiation does not take place continuously, but energy is emitted or absorbed in the form of packets or quanta called as photons. The average energy associated with oscillator can be given as epsilon is equals to h nu upon e raised to power h nu upon kt minus 1. The total number of resonators per unit volume in the frequency range nu and nu plus d nu is given as n is equals to 8 pi nu square upon c cube d nu. The energy density in the frequency range nu and nu plus d nu is given by E nu d nu is equals to n into epsilon bar. E nu d nu is equals to 8 pi nu square upon c cube into h nu upon e raised to power h nu upon kt minus 1 d nu. This equation is called as Planck's radiation law.